All right, let's get you logged in. Welcome to day 10 of your cybersecurity internship. Now, we're not just going to be sitting in a classroom today. Oh no, you are on the digital front lines. Your mission? To learn how to defend against one of the most disruptive threats on the entire internet. So let's get started. That's right. For today, you are a cyber threat analyst intern. You're working at a major fintech company. You made it through the first week, and, well, today things get real. Your team is counting on you to help protect our critical services from getting knocked completely offline. So here it is, your primary objective: to understand and defeat modern distributed denial of service, or, as you'll hear all the time, DDoS attacks. Think of these as just brute force digital sieges. The only question is, are you ready for the challenge? I thought so. Every good analyst needs a plan, and this right here is our training schedule for the day. First, we'll dive into the anatomy of a modern attack. Then, we'll build our defensive playbook. After that, you're going to get your first hands-on assignment, learn from some real-world events, and finally, we'll debrief on the future of cyber defense. Okay, first up, your threat intelligence briefing. You can't really defeat an enemy until you understand exactly how they operate. So this is where we're going to break down what a modern DDoS attack really looks like. So what in the world is a DDoS attack? Well, imagine trying to get into a sold-out concert, right? But there are 1,000 people with fake tickets all jamming the entrance on purpose. That's a DDoS attack, just in the digital world. It's a massive, organized flood of junk traffic coming from countless compromised computers and devices, all designed to do one thing: overwhelm a server and make it totally unavailable for legitimate users like you and me. It's pure digital disruption. And here's the thing, not all of these attacks are the same. They actually target different layers of a network. You've got your volumetric attacks. Those are the simplest. They just try to clog the network pipes with a ton of traffic. Then you've got protocol-based attacks, which are a bit smarter. They exploit the way servers talk to each other to just exhaust their resources. But the most sophisticated ones, oh yeah, those are the application layer attacks. They actually mimic real human users to take down specific websites or apps. And this threat has evolved like you wouldn't believe. I mean, back in the day, attackers used these clunky manual scripts and had pretty limited bandwidth. But today, we are facing smart botnets, these huge networks of infected devices that can be orchestrated by AI. We're talking millions of compromised IoT devices, everything from your home security camera to your smart toaster, all weaponized to launch a single, massive, coordinated attack. And this is the real challenge for defenders today. Modern attacks use AI to generate traffic that looks so human, it's incredibly hard to filter out. They use these short, intense microbursts to overwhelm defenses before they can even react. And they target the APIs that power pretty much all of our modern apps. The game has totally changed. All right, we get it. We understand the threat. Now, how do we fight back? It's time to open up our defensive playbook and start building our strategy. The foundation of any good defense starts right here, with this simple principle. This is the core idea behind something we call attack surface management, or ASM. I mean, think about it. Before you can build walls, you need to know the size and shape of the territory you're actually defending. Attack surface management is this continuous, never-ending cycle. First, you discover all your internet-facing assets, every single server, domain, and API. Then, you classify them by how critical they are to the business. Next, you assess them for vulnerabilities, you remediate or fix any issues you find, and then you monitor them constantly because your digital footprint is always changing. It's like you're constantly checking every single digital door and window in your entire enterprise, 24/7. So modern defense is all about layers. You have firewalls at the very edge blocking the obvious junk. Then there's rate limiting to prevent servers from getting totally overwhelmed. You've got web application firewalls and CAPTCHAs, those prove you're human tests that filter out malicious requests. And for the really huge attacks, traffic gets sent to these cloud scrubbing centers to absorb the flood. And finally, you have machine learning analyzing behavior to spot even the sneakiest, most clever attacks. Theory is great and all, but now it's time to apply what you've learned. Welcome to your very first assignment as an analyst. Let's get hands-on. Okay, so your manager just pinged you. The company's API gateway is seeing some really weird traffic patterns and performance is starting to drop. Your job is to jump into the logs and figure out what in the world is going on. So you pull up the logs. Okay,
Look right here at Attack ID DO2. It's targeting Layer 7, the application layer with what looks like an HTTP GET flood. And the indicator, the dead giveaway, an abnormally high number of repetitive API calls from all these different sources, all hitting the exact same endpoint. That is not normal user behavior. That, my friend, is a targeted application layer DDoS attack. Fantastic work, analyst.
You know, identifying an attack in a simulation is one thing, but now let's see how these concepts play out by looking at some of the biggest attacks in history. These are the lessons we learn from the field.
Let's start with a really big one, the attack on GitHub back in 2018. At the time, it was one of the largest DDoS attacks ever recorded, and it showed off a powerful and pretty scary new technique. The attack peaked at a staggering 1.35 terabits per second. That is just an immense amount of data, all designed to knock GitHub completely offline. But what's really incredible is that it didn't use a traditional botnet. Instead, it used a technique called reflection amplification, which basically means it tricked other innocent servers on the internet into sending a massive flood of data to the target for them. The key takeaway from the GitHub attack, and a similar huge attack that AWS stopped in 2020, is crystal clear. Your on-site hardware just can't handle attacks of this scale. You absolutely need a defense that combines your local tools with massive cloud-scale protection that can absorb these global floods of traffic. And the range of targets is just huge. Back in 2016, the Mirai botnet took down the DNS provider Dyn, which made major sites like Twitter and Netflix totally inaccessible for hours. Then, just last year, an attack on a major Indian bank targeted its financial APIs, showing that these attacks have really become a form of business warfare. Okay, this brings us to the end of your training day. It's time for your final debrief, where we're going to take a look at what comes next. And here is the big question you need to be thinking about as you move forward in your career. Given the scale of the threat, we're talking billions of insecure devices and AI-powered attacks. Can we ever truly prevent all DDoS attacks? Or should our goals shift from perfect prevention to unwavering resilience? You know, the ability to withstand an attack and recover in a flash. That's a question for another day. For today, congratulations! You've officially completed your training and you've earned your DDoS Defense Strategist achievement. Just look at the skills you've picked up: DDoS analysis, botnet intelligence, attack surface management, and maybe most importantly, cyber resilience. So, day 10 is in the books, but your work as a defender, well, that's never done. The digital world is counting on you. Your internship continues. Stay vigilant.